Hey, what's up, guys? This is Chung here again. So this time, today's daily challenge problem number 630, course schedule number 3. So you're given like n courses, right? From 1 to n, and so each course has like two property. The first one is the duration of the course, and the second one is the last day. Basically, the duration of the course and when's the last day this course can be taken. So you will start on the first day, and you cannot take 2 or more courses simultaneously, and you need to return the maximum number of courses that you can take. So in example 1 here, we have this kind of 4 courses, right? And the answer is 3, so which means we can take 3 courses in total. Yeah, and yeah, so here, there are like some like edge cases, if the end date, if the last day is even if before the duration, of course, we cannot take any course, right? So, and the constraints is like 10 to the power of 4. So, for this kind of course schedule issues, this one is a little bit, I think it's similar. It's a little bit similar to the knapsack problem. Basically, we just need to find among those courses, we have to find a bunch of courses, pick a bunch of courses, right? I think we can start with that approach, which means that we can try to pick some courses, right? But in order to do that, and in order to and the brute force is of course is n like factorial, right? Which means that we can pick any course, right? And then we can among the remainings we can also pick the rest. But this one will definitely TLE. So to have a better solution here, we have to somehow find a sequence of picking the courses. Since we only have 2 properties here, either duration or last day, we have to decide how to sort these courses so that we can find like a better sequence to process each course. We can either sort by the duration or the last day, right? And in this case, we should sort it by the last day, not the duration. So the reason being is that there's like we can have like a little bit of proof here. Basically, if we have like smaller duration, right, but has a bigger last day, right, I think it's always gonna be beneficial to process the course with the smaller last day. There are like different scenarios for that, but in the end, right? I mean, we can draw some like examples, but in the end, we can see that by processing the course with a smaller last day instead of a smaller duration, it's always better because let's say we can, for example, if we can process 2 courses, right, and then one course has like has a greater has a smaller duration but has like a bigger last day, and one course has like a bigger last day but like the bigger duration but smaller last day, right? I mean, we can draw in that case, we should always process the one with the smallest a smaller last day, because otherwise, if we pick that, if we process the smaller duration but with a bigger the last day, once we process that one, for the other course who has the longer duration but a smaller last day, we won't be able to have enough days to process. Assuming the duration, the total duration is smaller. It's smaller than the it's greater than than the smaller last day, right? In that case, we have to process the one with the smaller last day. Okay, so what I'm trying to say here is that so the conclusion is that we need to sort by the last day so that we can make sure we always following like a good sequence, right? And after that, we can always we can simply just do like a knapsack or a DP solution, where the we can have like the index, right? So the index is basically the current like course, and the second one is the time, right? The time means that with the total time we have spent so far to take that we have taken the previous courses, right? Because the reason we need the time here, is because from the starting point, we're gonna check all the we're gonna check out the courses from the index to the end. If the current one, if the course, like we have for each course we have duration and the last day, right? If the duration plus the current time is within the range, it's not exceeding the last day, then we know we can take this current course, right? Then we should increase the answer by 1, right? And then we we do the DP of I plus 1, right? Then the new time, the updated time in this case, right? And then in the end, we among all of kind of like possible scenarios, we return the ones that can give us the maximum number, right? So that's the first solution, but that one will lead to a TLE based on this kind of based on this this constraint here. I think so. Basically, this is the index, right? So I think there's like small mistake here. Basically, so the knapsack means that for each of the index here, we either take the current index or we don't take it, right? And we can always not take the current course, but to be able to take the current course, we have to satisfy this condition, right? Basically, the D plus the time would not exceed L, right? Maybe we can try to code that real quick. I'll show you guys what I mean. But this one will TLE in the end. So if I and time here, this one is like a DP, right? And then, like I said, we need to sort by the end by the last day, right? That's why we're gonna do the sort key gonna be the lambda, right? X dot x1, right? And then we simply return the DP 0 and 0. Okay. So if the I is equal to n, right, we return 0. So n is the length of the courses. Otherwise, so the answer is starting from 0, right? Since we're getting the maximum, and not take current course, right? It's going to be answer going to be the max of answer dot dp of I plus 1 dot time, right? And if we take the current course, we have to check, right? If the d plus, sorry, not d. So we have the duration and the last day going to be the courses of I. So if the d plus the time, the current time is not exceeding the last day, then we can take the current course, which means it's going to be a max of dp answer.dp I plus 1 d plus time, right? And then plus 1 since we're taking one course, right? And then we return the answer. Yeah. So that's the basic idea here. You know, if we run the code, this should work. But this will TLE based on given this kind of IN time here. You know, this is actually it's an N squared time complexity, right? So which means we need a better solution, you know, to solve this one. So to better solve this solution, we need at least an n log n solution, right? Which means that, you know, lead us to a greedy approach. And so a greedy, what does it mean? You know, okay, so once after sort this one here, sort the courses here, you know, when we have like a current course, we only have two options, just like what we have here, right? And a greedy approach is that, you know, we always try to take the current course if whenever it's possible, right? But if we cannot take the current course, so what are we going to do? So if we cannot take the current course, we'll look back. We'll try to see if there's any course that we have taken previously who has a greater duration with the current duration. And then we're gonna swap those two courses. And why is that, right? So let me show you guys. So let's say we have courses have a duration of let's say we have taken like 3 courses, right? So the 3 courses we have taken have the duration of 100, 200, and then 300, right? So let's say this is the courses we have taken previously, and now we have like the third course. Let's say the third course has like a duration of what? Let's say 250. This is the current duration. And this one, let's say, you know, the time we have taken is what? It's 600 in total. That's the total time. So let's say, for example, the current course has like the duration of 250, and the last days is 500. That's why we cannot take the current course, right? Because actually it's not even 500. We can even give it like a bigger one, you know. Let's say it's 700. Because, you know, 600 plus 250 is greater than 700. That's why we cannot take the current course. So what are we going to do? Since we cannot take the current course, you know, we'll basically go back to check if there's any course we have taken previously who has a greater duration than the current one, and we do have it. It's 300. So which means we're gonna swap those two courses, which means that instead of taking the 300 course, now we're taking this 250. And then we're gonna remove this one. We're gonna not taking the 300. And while we're doing this, right? So what's the benefit of doing this? Because since at this moment we can only take 3 courses in total, right? So that what we're trying to do here is that we're trying to see if we can reduce the total number of times we have taken we have taken for those 3 courses. If it can, we simply will just reorganize our options, right? So that we can minimize the total courses the total time we have been using so far. Because by doing this one, you know, will be instead of 660, we'll have like what? We'll have like 550 total time. Which means, you know, it's gonna give us like a better chance for our future courses to be taken. That's the whole idea of this greedy approach. And if there is nothing, if there's no course that can be greater than the current one, right? Of course, there's no point to swapping that, because by swapping that, it will only make the total time become bigger, right? So with that greedy idea here, it's clear that we need to have maintain the biggest, right? The biggest, like the biggest duration for the courses we have taken, which is a perfect candidate for the priority queue. And so let's do it then. So again, we still need to sort, right? Because that's the first prerequisite to make sure we're following the correct order to process each course. Now this time we have the priority queue, and then we have the time, right? Go to 0. So for D and for the duration and last day in the courses, so if the time plus the duration is within the last day limits, we'll simply just take the course, right? Which means we're gonna push the courses into the duration of the course into the priority queue. And since we're trying to maintain the maximum, right, duration, we're gonna use the negative value of the duration. And then we're gonna increase the time, right? Else, actually it's else if the priority queue is not empty, and what? And the biggest one, and the biggest duration we have taken so far is greater than the current D. That's when we need to swap, right? And how can we check that? And basically the first one is the biggest one, right? Since in terms of this a negative value, that's why we have to use a negative version of it, right? To compare with the D here. If the biggest, right, duration, right, is greater than the current duration, right, then swap, right? Swap means that we're gonna remove that time from this priority queue, and then we add the current duration back. So which means that we're gonna add the difference between those two, right? So we add the current one into the time, and then we're gonna remove the one. Since this one is like a negative values, we're gonna use a plus, right? Plus the heap queue dot heap pop priority queue. Okay. And then don't forget to push the current duration into the priority queue. Since we know we're saying that, okay, now we're taking the current one, right? And to replace the one of the previous course. And then in the end, right? In the end, actually the length of the priority queue is the maximum courses we can take. Accepted. Yep, there we go. So this one is pretty fast because we're using a priority queue, and this one is unlog n solution, since we only store this one, right? And then here we have an n course, and then we are using a priority queue. That's why it's fast enough to pass the test cases. Yeah, I think that's it. I think this one is a little bit tricky. First thing is that we have to basically to convince ourselves, right? I mean, sort by the last date is a correct way to process all the courses, right? And I think this one it shouldn't be that hard to come up with. This simple like a knapsack problem. But for the greedy one, for the greedy approach, it's always kind of hard to prove, right? And for this one, basically we're greedy in a way that whenever we cannot take the current course, we look back to see if there's any way we can improve our options or our choices, right? By only taking the courses that has the smallest duration, right? So this one actually is a little bit like uh, similar to like greedy, not greedy, sorry, the lazy greedy approach, right? I mean, there's like another similar like the jump building problem. You're given like a bunch of like the bricks and the ladders. Similar as this one. We uh we, we keep going, right? We're going to a point that we cannot keep going, and then we look back to see if there's anything we can do to improve our previous choices. In this case, it's like by removing the biggest duration if possible, right? And then yeah, and then we keep going, and that will guarantee us to always follow the best approach. Um, yeah, I think that's pretty much everything for this problem, and I'll just stop here then. Okay, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.